I'm Raymond de Jong. I'm Dutch, field CTO of EMEA at Isovalent. I live in Switzerland in the beautiful canton of Schwyz, and I enjoy hiking, biking, cycling, all that stuff. And I'm also nicknamed by my colleagues as ambassador of Switzerland tourism. So if you want to know anything about Switzerland, I can help you. I work for Isovalent. Isovalent is the company behind Cilium, eBPF, which are donated to the CNCF as open source projects. We still contribute 65 to 70% to those technologies. And if you want to contribute, feel welcome to contribute as well. We leverage eBPF as the underlying technology to basically reinvent security and networking. How many of you actually know Cilium? Quite a lot already. So maybe I can skip a bit quicker through the Cilium introduction slides. And how many of you know about eBPF and why we use it? A couple of hands. Okay, cool. Good to know. So Cilium is the networking, observability, and security product to secure your Kubernetes workloads, whereas Tetragon is our fairly new solution to also secure runtime events. So everything related to a Linux operating system, processes, files, and so forth. The talk today will focus on Cilium. If you want to know more about Tetragon, feel free to visit us at the booth or to ask questions to me after the session. So the agenda, I want to talk about some strategies you can adopt while you're running Kubernetes and to adopt network policies, which is not easy. And then I can jump in how Cilium, with provided tools and visibility, can help you to achieve your goals for running multiple tenants, multiple workloads on Kubernetes. I'll talk also a bit about ingress and egress, thinking how you can integrate solutions such as ingress controller, gateway API, which is built into Cilium, using BGP, LB IPAM, and so forth to successfully attract traffic. And also talk a bit about egress connectivity as well. And finally, showing observability as the network policy superpower, using Hubble built into Cilium to actually give this visibility so you can actually see what's going on and how you can successfully secure it. And if there's enough time, I will also demo that in a live environment. So let's get started. So zero trust security is all about micro-segmentation, securing namespaces, applications, even considering security on API level, so layer 7 as well. Cilium can be sort of your API gateway as well within your cluster. About securing east-west, north-south traffic, so both in your cluster, but also attracting traffic in and out the cluster. Preventing data loss, making sure you have visibility and monitoring, data operations. A lot of our customers have regulated environments, so compliancy and regulation is important. And then obviously you also want to be able to monitor and audit your environment to ensure you're compliant. Some typical challenges are obviously scale. If you run big Kubernetes clusters, you have tons of applications, with each application consisting of multiple services. Understanding how they communicate becomes really important. A risk here is also granular policy management, which I will talk a bit as well. If you run across clouds, you want to have the same constructs. Maybe you want to have high availability across clouds. How would you approach that specific challenge? Access to external services. Maybe you need to connect to a database somewhere in the network which has critical data. You want to secure that access. Also the DevOps agility, right? The ability to unblock your developers as best as you can, provide self-service where possible, automation, and so forth. And obviously training and knowledge and be able to troubleshoot your environment. So like I said, there is no real easy button yet for adopting network policy. We see different use cases, requirements requiring different approaches. This is also not an AI talk, so we have not yet AI technology which can do this for you automatically. Maybe in the future. So basically you can have 3 options. One is obviously allow everything, but in production that's not really recommended and most likely not wanted. A default deny. That can work, absolutely. Requires you to see the documentation, go through the firewall requirements, understanding specifically what tools you use on Kubernetes itself, besides Cilium and your applications. There is an excellent talk done by Schuberg-Phillips, how they achieved it for a PCI DSS regulated environment. If you want to check that out, highly recommended. But it comes down to good preparation. Cilium has an opportunity to put Cilium in a audit mode, which doesn't enforce the policies, but will show you if any traffic is dropped. So you can test drive this default deny setting, if you like, before you actually enforce it. There's obviously a risk of locking yourself out if you don't prepare this properly. What I'm focusing today on is a practical method which focuses on risk reduction. So give you an approach you can use to be able to secure your cluster and your tenant workloads, but also find the middle ground of where to get started without blocking your developers, for example, too much. This is dependent on metrics for risk exposure, which I will talk about. We're recommended to focus on the most secure namespaces and services first. Obviously, leverage the tools you have to confirm it's working as expected and to continue to operate the platform, and then iteratively expand across the workloads in a similar way, and obviously applying CI/CD workloads and automation. Also, a typical problem is that running a Kubernetes cluster involves different personas. So security teams require you to be compliant. You have specific security requirements. On the other hand, as a platform engineer, you need to facilitate the onboarding of applications. So you're in the middle of these two forces, which have different, different expectations and requirements, and you need to be able to allow them to be most effective while being secure. Typically, a team or a tenant has obviously one or more namespaces, so starting with a namespace level security makes sense, and I will show that a bit later. Before diving into these metrics to identify risk, I want to talk a bit about the types of risk exposure. Obviously, the most risky is external access from internet, external networks into your cluster. If you potentially have, for example, routable pods running in your cluster and don't secure them, someone can potentially exploit that. So that's something to consider. Or when you accidentally expose the service to the external network, someone can exploit that access as well. Then we also have this egress internet exposure. Maybe you need to connect to resources in the cloud or on the internet or in your external network, a database and so forth. So understanding what you need where is vitally important. You also want to avoid data exfiltration and other really risky events. Also, lateral movement between a cluster, between clusters, but also inside a cluster is a typical risk exposure. So the goal is to reduce unused access to minimize risk. And you don't want to create exposure for any services or applications you don't actually need. So one example is you want to obviously avoid that if someone exploits a pod that he can go east-west within your cluster or even exfiltrate data. So instead you want to put some guardrails in place to get started and to make sure that each namespace is secure and then iteratively expand through ingress and egress and other policies as well. So measuring risk, concrete measurements to guide priority, to give you priority to specific exposure is obviously the number of services you expose through a load balancer or a node port or an external IP. Obviously, if you use ingress and gateway API, is a very good measurement. The number of services reachable across namespaces. Maybe some namespaces need to be able to communicate with each other, so that's also a risk exposure metric. And obviously the number of services which has to have access to external resources. And going through these numbers, especially the ingress and egress, if you can quantify that and monitor that, you'll be able to be more in control of your workloads. So initial network baseline strategy would involve creating some kind of baseline policy. So in this example, you could be able to secure traffic within a namespace by using a simple network policy, which selects all the pods in a namespace, allow traffic between pods in a given namespace, but not necessarily ingress and egress. Obviously, you need to consider kubedns and other tools in your cluster to be able to communicate. That's required, it's infrastructure, it needs to have that done. At scale, we recommend to use cluster-wide network policies to achieve that, but you can also do that on a namespace level if you want. When workloads in a given namespace need to be able to access that there are also ways to make that more narrow. So instead of just exposing a given service through load balancer, we recommend to actually narrow that down through a gateway API resource to expose a given gateway. A gateway gives you the option to filter on layer 7 and only expose specific paths if you want to specific services. That makes it already less exposable. And then use other network policies to secure access to external resources based on FQDN or obviously IP or CIDR if you want. And this will be dependent on your application, and I will show how you can use Hubble, for example, to monitor that and to learn about that traffic. And at even bigger scale, we recommend to think about GitOps, CI/CD pipelines, leveraging automation to control PRs from teams to automatically filter, for example, network policies which require some kind of default allow or too broad CIDRs or any as a destination and automatically drop that. So that's something we see in practice with our customers where they put this automation in place. They provide this self-service to their tenants while you as a platform engineer can secure your cluster providing guardrails using cluster-wide network policies and automate the creation of namespaces with a given set of default network policies, so you are ensured it's secured once they onboard the application. All right, so this was a bit the introduction of the strategy. I want to move more how Cilium can help you with that and then show in practice how that looks like. So some of you know about eBPF. I need to talk a bit about eBPF before I can dive into Cilium. eBPF is, if you like, the engine of your very fast car, which is called Cilium, right? We also like to say that what JavaScript is to your browser, eBPF is to the kernel. And what that means is we make the kernel programmable, extensible in a secure and dynamic way. And depending on the features you need, we can add code, logic into your kernel to achieve certain things. So in the context of the session of today, think about all networking related events related to a pod connecting to a service. Is the traffic allowed? Do we understand the source and the destination? Do we have a network policy in place? And using eBPF, we can actually inspect, observe, but also secure the traffic and prevent from connectivity to happen. Cilium is built on eBPF. Depending on your requirements, you can configure Cilium for all your networking, observability, and security use cases and requirements. And Cilium will happily use eBPF under the hood to achieve that goal and give you the right performance. So let's talk a bit more about specific Cilium policy, network policy features you can leverage to achieve the goals I've mentioned earlier in this session. Before diving into the features, I want to explain a bit about identity-based security. So instead of looking at pure IPs, we're actually looking at identities. So Cilium cares about identities, and that makes it more scalable. You can have a deployment of hundreds or thousands of pods with similar metadata. They are all the same front-end app Nginx, for example. That can happen. So we are not interested in the pod's IP address for each one of them. Instead of, we are interested in this specific set of labels, and they share a common identity. And at scale, that makes securing and observing traffic from a given front end, for example, to a backend, way more performant. That's also the case for things like destinations as DNS or cluster and other sources as well. So how does it work? So for example, you have 4 pods called frontend. They have that label. They share a single identity. They want to connect to a backend, which has a different set of labels, therefore a different identity. And Cilium, depending on your network policies, will allow or deny that traffic. Any other source which is not allowed in a given network policy will therefore be denied. Besides that, we can also support layer 7. So beyond layer 3, layer 4, we can also prevent access to specific layer 7 paths. So using HTTP API GET method on a specific path can be secured compared to, let's say, an API method POST, which is not allowed. So that level of security can be achieved using Cilium. We also support Kafka, Cassandra, and some other protocols as well. So how do you achieve that? We have common resources called Cilium Network Policies. We also support Kubernetes network policies, by the way, but the Cilium network policies are more capable of all these layer 7 and DNS-aware capabilities. So this is an example of a given CRD, a network policy which allows not only on port 80 traffic, but also only a specific method on a specific path. For egress connectivity, a common use case is, for example, securing access to maybe a bucket on S3, right? You may know that such kind of resources, the underlying IP constantly changes. So trying to secure access to such resources is almost unachievable with just IP addresses. So instead, you can use DNS-aware Cilium network policies where you can define 2 FQDN rules to allow specific access to specific FQDNs. And you can also use wildcards and regex methods to actually allow that access. So that makes it way more scalable and flexible in that kind of environments. You may have heard about, I said it before, right? You can secure on namespace level, and you can also use cluster-wide network policies to set these guardrails. And if you run cluster mesh across multiple clusters, you can use Cilium network policies across clusters. That means that you're not only able to secure a given front end to back end, but you can also specify only a specific cluster where this traffic is coming from to allow it to reach a traffic or a resource at another cluster with a different cluster name. And you can mix and match those cluster names as well with different policies. And Cilium understands the identities in each cluster and keeps track of where those workloads are. So what about ingress and egress? So what about securing this traffic coming in your cluster and traffic leaving your cluster? Typical use cases are exposing applications to your external users, your customers, using Gateway API or ingress resources, or maybe other methods. You can leverage Cilium built-in ingress controller or Gateway API controller to achieve that, but maybe you have other methods as well. So you need to consider access from those resources using ingress or Gateway API into your cluster. And also egress, connecting to external resources, a database, and external IP. Typically in enterprise environments, a given network administrator or firewall administrator don't want to allow access to this critical database on the whole node IP address ranges or specifically pod IP address ranges because that's too much of an exposure. Same story as I explained before. You can use egress gateway, for example, to have a specific source IP to reach those destinations. So you need to consider external firewalls, clouds, and so forth. And another challenge is routing traffic. So think about maybe you have a managed service provider environment or you're managing multiple Kubernetes environments, maybe for different teams. And some teams need to route through the network in a different way. So this is more about having specific IPs for specific workloads to be able to use, for example, BGP to route that traffic in your network in a specific way. That also gives you optimization options and gives you also security options in terms of separating traffic from a given source to a given destination. So Cilium also has a BGP control plane. I will not dive too deep in this feature, but this allows you to assign specific IPs to specific services and advertise those IPs to the external network so the network automatically learns about this service and how to reach that service. We released in Cilium 1.16 a new BGP control plane. We introduced new services. Tomorrow I have a session where I show them as well. So if you start with 1.16, I recommend to use these new CRDs, which will be the new control plane moving forward. To make IP allocation flexible for ingresses and gateway API, you can use the LB IPAM capabilities, which is basically our operator, our Cilium operator, keeping track of IPs with specific labels. So you can have a blue, a green, a yellow tenant, and based on the labels, we select specific IPs from specific pools. And those IPs will be used to advertise to the network and allowing you to route traffic on the external network more effectively. And finally, Gateway API. We built in Gateway API support in Cilium to be able to be that entry point from north-south perspective to attract traffic on a given path. And there are ways to integrate a given gateway with LBIPAM capabilities. So let's say I have a blue tenant, and this tenant needs to have specific IP addresses or a specific IP pool to be reachable on the external network. What you can do is use the new infrastructure labels in Gateway API. I do believe they are still on the experimental channel, so keep that in mind if you want to test that out. So that means that I can add labels to this gateway resource, which allows the load balancer to be created to be able to attract traffic on a given port, to add that labels automatically as well. And that will trigger Cilium's LBIPAM feature to select a specific IP from a specific pool, which you can then in turn advertise using BGP to the external network. And finally, egress gateway. I mentioned it a few times. Like I said, you want predictable IP addressing leaving your cluster. You don't want to expose the whole cluster to a given database or given service in the cloud. Instead, you want to have dedicated IP addresses to have traffic leaving your cluster using that IP, and then allowing you to use an external firewall or other resource to only allow that given IP to that given service. So that brings down this exposure on that side as well. And that's done through Cilium Egress Gateway Policies, which don't have time to look too much on it today. And if you want to see this all together, we actually have a demo showing all these capabilities together tomorrow at our booth, so feel free to join us there, where I show all those new resources and how it actually works in practice with multiple tenants. So let's switch back again to Cilium and observability. So obviously observability's goal is to give you tools, visibility of live flows, what's going on in your cluster. And obviously we saw the need of, at scale, to be able to operate your cluster and to understand what protocols, what communications are going on. And for that reason, we designed Hubble, which is part of Cilium, and gives you a UI, a CLI, but also metrics you can export to Grafana to observe traffic in real time and to make an informed decision what traffic to allow or to block and to monitor your workloads, right? So if you have an application, maybe your application team creates a new version or introduces a new service, Hubble UI can give you this visibility on a namespace level, what's going on. So in this screenshot, you see a namespace called tenant jobs. We see all the communication between those services. We even see also external communication. We see live flows, even layer 7 information, in this case, put methods on a specific applicant's path. And with this information, you can create network policies. To help you with that, we have actually created a site, a website, which allows you to use a UI to draft a network policy you can use. If you're not fluid in network policy YAMLs, you can use this website to actually design your network policies. So I recommend to use that as well. And finally, we also worked together with Grafana, and we have exposed or shared a policy verdict metrics dashboard. So this relies on all the metrics Hubble collects and exports to Grafana. And this dashboard shows you, for example, the amount of flows, if they are matching a given network policy, but also what kind of policy that is, if it's layer 3, layer 4, if it's layer 7 or DNS based, and also obviously drops, or when it's not matching, right? So that can be an indicator that you need to do some work to make sure that those remaining flows are matching, and that we'll show that in a demo. All right, I have 7 minutes left, so that should be enough for a demo to see this in action. All right, let's go. Let's start Visual Studio. Can everyone in the back read this? Cool. All right, so let's start with Hubble. So there's a ton of namespaces here, and I'm starting with this little application. I hope the demo gods are with me. Uh-oh. Am I on the Wi-Fi? Yep. Oh no, what's happening? Let me try again. Oh, no, 3.5. Yeah. No, there are not network policies there. What's going on? Oh no, that's crazy. I've been dropped some connection in between. Let's see. Uh-oh. Okay. It just worked before I entered the room. Jeez. All right, bear with me. Yes, it is. No recordings whatsoever. Oh, can I? Sorry. Now see me panicking and sweating on this whole day. I don't have a network. Okay, let's reset the Wi-Fi. Okay, let's disconnect the VPN can also be a reason. Yeah, there we go. All right. Phew. Now look. Okay, cool. I managed. So this is a little example. We start with a small example where a client talks to a server. So this is just a simple service, a simple example, and we're going to observe traffic real time. Now we start with this default allow, right? And we want to step by step see what's going on and make it more secure. We also have this Grafana dashboard running in the background, so I can also see, as you can see, we have no matches, we have no policy verdicts matching ingress and egress traffic. So our goal is to have all ingress and all egress traffic matching a network policy. All right, so the first step is, as you can see, we have this going on, and we can see this client is connecting to world. Okay, that doesn't say a lot. We can find the IP address. So we can use this DNS-aware network policy capabilities to understand what domains it connects to. So let's narrow that down. So the DNS network policy. So you can create a simple network policy. I hope everyone can read it. This can also be found on our documentation website, where you just want to learn all the DNS requests in your namespace by allowing port 53, on protocol any, and with all patterns, right? Let's start with that. So I'll do a quick kubectl apply file, and I'm on the wrong directory, so let me go to the policies. So there should be, yeah, okay. So let's deploy this network policy and see what's happening. Now you can see we actually learn what domains, FQDNs, this workload is connecting to. In this case, Cilium.io and isovalent.com. And obviously I want to allow that, that's fine. So I use this information to make a next network policy to allow this client to connect to these destinations only and nothing else. And obviously allow it to connect to this server backend, because I'm assuming that's required. On the policy verdicts, I should see also immediate change, right? So I now get some flows matching with a policy, and I see this bluish graph starting and this green graph. So the blue indicates, in this case, layer 7 HTTP traffic, and the green indicates layer 3, layer 4 egress flow. So that's also indicating that part of the flows are now secured and matching a policy. Next step is this client. Let's start with that. All right, so I have prepared a client network policy. In this case, what I'm going to do is I'm selecting all client workloads. I'm doing this part to deny all ingress work traffic for this client. I don't need it, so using this line, I secure that. And then egress, I match the server endpoints on a specific port. I also need to include kubeAPI to be able to give Kubernetes to allow that feedback loop and that API control traffic to run. And with the information I learned from my previous network policy, I only allow these FQDNs on a specific port. So let's try that. All right, create it. And now we should, on the Hubble side, I don't expect much change, but again, there's nothing changed on the egress side. And it's still allowed to connect to the server. We just made it a bit more secure. But on the policy side, we should see a change in a minute as well with all the policies, all the flows matching this network policies I just created. So I don't wait for that because of time. Next step is the server. We need to secure ingress connectivity to that server on port 80. So let's assume this is HTTP and I want to allow that. I drafted a server Cilium Network Policy, selecting the server workloads from endpoints client, so only from the client on a specific port, and allowing HTTP. And in this case, I allow all HTTP methods and path, and possibly I can narrow that down later on. But let's keep it simple for now. Apply this network policy. On the server side, there's no change, except that we now see HTTP appearing. So now Hubble, using this network policy, understands actually the protocol and shows that information. So if I zoom here, you see we can actually learn the method and the path. With this information, I can make additional steps to only secure specific methods on specific paths if I want. So this is super powerful. So basically now I have 3 network policies in place, and we should also see ingress verdict rate change, as you can see. So we're also now matching ingress flows with a given network policy. So we're getting there to match all this traffic. And the final step is obviously dropping this default allow. All right, so this is the rule I prepared, and I'm doing a delete, so nothing should break. We have enough policies in place to make it work, and it seems to remain working. We see you forwarded, and so forth. But in this case, this application is not being accessed from the external world. So let's assume that we need obviously ingress. We need to be able to make this available to our users. So let's try that, right? Okay, so I have actually prepared an ingress resource for this purpose called app ingress. I grab this IP quickly. Then I'm able to I'm able to access this resource. I think this is still my cache. So let me do a quick Ctrl+C, because that should not happen. I should see drops. So now you see ingress appearing. So keep in mind, this is my cache. I tested this demo, but I can confirm that because I see this drop, right? I see this red line, this red dotted line from ingress. If I click on the server, I can actually see all the flows related to that. So we now observe ingress traffic into my namespace to my server workloads. And there should be some drops as well. I can filter on drops. Here you can see request I did just now, and the traffic is dropped because the policy is not configured for that. So let's fix that by just adding this ingress part. A common request is, can I also filter on source IP? That's something we're building as we speak. So that will come in the future. For now, you need to, if you use Cilium as an ingress controller, you need to allow it from ingress to make that work. All right, so apply this file, server.yaml. And now, if I should refresh this a couple of times, we should be able to see also allow from ingress in this case. Yeah, now I see forwarded. So now I've allowed this external access to this application. This was a fairly simple example. Obviously, in real life, you have more complex jobs. So this is, for example, a tenant jobs application. A lot of stuff is happening here, as you can see. Also, external access to api.github.com. We can even see Kafka traffic, Zookeeper traffic, and so forth. So obviously, if you leverage this method for such an application, it requires a bit more rules. And I will show quickly what you can think about as a good starting point of such an example. So you start with this allow all within a namespace to allow intra namespace traffic. You create a DNS network policy, allow network policy. In practice, at scale, you would do that with a cluster-wide network policy, but this is just an example. Again, allowing all this 53 DNS traffic to kubedns. And then define an egress policy. So in this case, we are allowing api.github.com. We are allowing HTTP, and also on specific ports only, with HTTP as well. And we have another 2 ports for specific traffic in that namespace for egress traffic to allow that from workloads in your namespace to other workloads in the same namespace. And on the other hand, on ingress, you have the same story, allowing some specific ports on HTTP and another port entry for Kafka. And again, you can filter it even more. So just 4 network policies to make that happen for such an example. And you're already pretty much in a good state to move forward and be comfortable that your application is running securely. I'm way beyond my time. I apologize. I need a beer as well. So let's get finishing this session. First of all, if you want to learn more, if you want to try this out yourself, we have excellent labs available on isovalent.com website, free to use, instruct environment, interactive. You can learn about these capabilities. And you also get badges for certain labs, so you can proudly share and show them on LinkedIn. If you want to know more about Cilium, check the documentation, join our Slack space, join GitHub. And if you're more interested in eBPF, we also have a dedicated website for that as well. So with that, thank you for your patience and for your time, and enjoy the beer outside.
Thank you very much for the very nice demo.
Questions?
Yeah. We have just 5 quick questions, and then everybody can have the well-deserved drink. Like the top one, can Hubble do NetFlow monitoring?
NetFlow monitoring, not yet, no.
Okay.
No. That's quick.
Yes.
In a way, Hubble has its own way of showing all these flows, right? We don't necessarily need NetFlow to achieve the same purpose.
Okay. When developers create networks policies, how do you manage which targets they can create?
Yeah, so that comes down to automation, GitOps. You can use, typically customers in production don't allow teams to apply automatically CRDs themselves. They go through a check, some kind of automation. One example is one customer has, specific IP addresses where they have very secure workloads. So anyone trying to create a network policy with that destination that PR will be denied automatically.
Okay.
So you can use that kind of methods to filter too broad or too specific IPs.
Okay.
And such.
Next one, layer 7 network policies. Can they be used with encrypted traffic?
No. If it's encrypted and you want to inspect traffic with HTTP, that's not feasible. Again, this depends on how you want to implement your environment. You can, for example, leverage instead Cilium encryption, transparent encryption using IPsec or WireGuard for pod-to-pod encryption in your cluster, and then do, for example, TLS decryption on the ingress or gateway resource to allow this visibility on layer 7. Traffic within the cluster is obviously encrypted, but the layer 7 is visible. So that's a design consideration you can consider to apply.
Cool. The last 2 one, I don't understand this one, but maybe you will.
Oh, yeah, I do. Yeah, LB IPAM is compatible with layer 2. We have this layer 2 announcements capabilities. I didn't mention it because typically enterprises are more comfortable with BGP, and using a layer 2 for services, you're dealing with gracious ARP and when a different node gets selected and stuff. So it's not as solid as BGP. But yes, you can select services with specific IP addresses using layer 2. Yeah.
All right. Last one, information about VM gateway.
Yeah, so it depends a bit which VM gateway they understand, but we do support, depends if they understand, if they want to know more about a transit gateway we talked about before, or something else. But we do support, for example, a VM in the context of Cilium. So you can install a Cilium agent on a VM. That VM becomes part of the Cilium data plane, and therefore you can create network policies allowing that traffic. We've also talked about something we're building still, and that's this transit gateway, which allows you to connect to external resources through a single node or pair of nodes as a Cilium gateway resource. That's still built. So if you want to know more, feel free to reach out to me, and I'm happy to discuss that. But it's not yet available to everyone.
And with that, thank you very much for today. Thank you very much, Raymond.
Thank you.
You deserve the beer, and everybody else.
Thank you so much.
Please enjoy the evening. Goodbye.
Thank you.